Python. So Python has emerged as a powerhouse in the field of data science, offering a versatile and comprehensive ecosystem of libraries and tools. Python, a general-purpose programming language, has become a dominant force in the realm of data science. It is known for its readability, flexibility, and a thriving community. Python provides a robust foundation performing a wide range of data-related tasks. Some popular choices for external integrated development environments can include Visual Studio Code, Jupyter Notebooks, and Google Colab. These are all free. So some advantages of Python is that it boosts a rich ecosystem of libraries that is tailored for data science. It has some libraries such as Panda and Matplotlib that are the backbone of data manipulation, analysis, and visualization. It is the forefront of deep learning thanks to TensorFlow and PyTorch. These frameworks enable the creation and training of neural networks for advanced machine learning algorithms. It is an open source software that fosters community-driven development. A vast community of contributors continually enhancing libraries and tools. This ensures that Python stays at the cutting edge of data science. Its popularity has led to a wealth of online resources, tutorials, and documentation. Whether you're just a beginner or an expert, you will find abundant support as you navigate your Python data science analysis. Python seamlessly integrates with big data technologies such as Apache Spark and Hadoop, while allowing users to scale their data science workflow to handle massive datasets. Python is widely accepted in the industry from startups to large enterprises, making it a valuable skill for professionals entering the field of data science. Here we would look at some disadvantages of Python. One significant disadvantage of Python is its memory consumption. Python's dynamic nature means it consumes more memory than other languages, which can be an issue when dealing with large datasets or applications where memory efficiency is crucial. Since Python code is not compiled beforehand, some errors only become apparent during execution. This feature can lead to longer debugging times compared to other languages. The speed of Python is another area where it falls behind other languages. Python's execution speed can be slower compared to other languages like C or Java. This slow execution can be a limiting factor for applications that require real-time responsive or high performance. So Google Colab, it's open, free source, it is online, so it's shareable. Multiple people can work on it at the same time. So Google Colab allows you to write, run, and share Python code in your browser. It requires zero configuration, free access to powerful GPUs, and easy sharing. So some basics in Google Colab. So Google Colab Notebook consists of cells that contain either text or code. So you can add a new cell by clicking plus code or plus text button at the top, or you can hover in between cells to see these options. So right here you have code, text, or if I just go in between, I would see that it appears. So your text cell, so this here is a text cell. So if I double click on it, I would see an editor. And then basically, if I just double click here, the editor disappears and it shows the text. So this could be used to add explanation, documentation, or comments to your code. Code cells are using for writing and executing Python code. So to execute your code, basically what you can do is on the side here, you just click on this play button and it executes. So here we can see that we want to print hello world. So what you do, you type print, that is the function, and in between the brackets, you type hello world. And it appears at the bottom here. Also, you can just use Shift and Enter and it will run. So Google Colab automatically saves your notebook to your Google Drive. However, you can click File at the top here and then choose Save to force a manual save. So in Google Colab, we have libraries and dependency. So Google Colab comes with many popular Python libraries pre-installed, such as NumPy, Seaborn, Pandas. However, if you need additional libraries, you could install them using the import command. So at the bottom here, we would see that I would have used some import commands. So these were pre-installed, but what I wanted to do was save them as aliases. So basically, these libraries are important for various tasks related to data manipulation, visualization, machine learning, model building, and pre-processing. They provide the essential tools and the functionality to streamline data analysis and machine learning workflow. So as I said, these libraries can be given aliases, which makes it easy to access functions and methods. So what I'm basically doing here is that I'm saving the Python library as PD. So throughout my notebook, I'll be referencing this library as PD. And as mentioned before, you have variables. So variables is a symbolic name that represents a stored value in the computer's memory. It allows you to store and manipulate data in the program. So some naming conventions in Python is that it can consist of letters, both upper and lower, numbers and underscores. It must start with a letter, either uppercase or lowercase, but I prefer lowercase. Variable names are case sensitive. So here you have two different versions of my var. You can see that the M is common first and then it's capital in the other one. So that means it's different. And variables cannot be the same name as Python keywords or reserved words. So some example of these are if, for, def. And some best practices is to use descriptive names to reflect the purpose or content of the variable. You can use lowercase letters for variable names to improve readability and consistency. You can also use underscores to separate words and variable names to improve readability. And we have an example here, snake case. So here we want to store 5 in a variable x. And to read that value of x, we just run x by itself. And we can see here that 5 is stored in x. So this script is pre-run, but you can go ahead and run it. If you're having any issues, you can let us know by commenting in the chat or just putting on your mic and letting us know. So as well as not only numbers, but you can also store strings or text. So what I wanted to store was John, and you can see it's in quotation marks. And then I read it with just running name, and you can see John was saved in name. So we'll be using the same dataset throughout this workshop, which is the University Edition 2024 dataset. So here I would just have a short description. If you choose to store your data in your Google Drive, you could also refer back to workshop 1, where they actually take you through storing that file in your drive and mounting it to be processed in your Google Colab. But I prefer having my file on my desktop. So you could upload your files from your local system to the current directory into your Google Colab environment. But the file that we will be using, because there's a train file and there's a task file, so we'll be using the train file first. And the dataset in this file is used to train the model parameters to adjust the initial settings to make accurate predictions. During this phase, the model learns from patterns and relationships presented in the data. So if you have your file stored on your desktop and you want to import it, you can use this command here. Now, when you run this command, you will see choose file. So you simply click choose file and you will see that you can go to your desktop if you have it saved on downloads or documents, and you could choose the file and click OK, and it imports. It also tells you the percentage. Depending on how much data is in the file, it might take a long time, so it comes in handy. So now that I have uploaded my file, I want to load my dataset into a data frame. Data frames are used to store and manipulate tabular data. It is a two-dimensional structure where data is organized in rows and columns. So for this here, I would like train data to be the name of my data frame that will store my data that is in my CSV file. So the name of my variable is here, and PD, that what I mentioned earlier on, is the pandas library. And what I'm doing, I'm going to use breed CSV. So if you hover over it, it does tell you, give you a little bit of description as to what it is, which is very helpful, especially for beginners. And then in here in the brackets, I have the name of my file. So I want to make sure my data is imported correctly. So I just want to have a glimpse of the few rows in my data frame. And to do that, I would use the print function. I will pass my data frame dot head. And once I run this code, I will see my dataset appear. So this just basically gives you like the first 5 lines of your dataset. Now, just looking at this here, it doesn't show you all, because you can see it's just 5 rows and 83 columns, but this definitely is not 83 columns. You can see these dots here is where they just left out some. But I can see here BMI that we had saw earlier on has some missing values. And then you can also see which of these columns are numeric and which has characters in them. So this definitely doesn't tell you how many rows, it just tells you 5 rows. But sometimes in the dataset, in the description, they will tell you how much rows are in the dataset. And to make sure all is imported, we can run this command here, which is print train data.shape. And here we can see how many rows and columns. So this here is imported correctly. So now we will move on to data types. So in Python, we have numeric. So numeric can be integers, which are positive and negative whole values. Then we have floating point numbers that are positive or negative whole numbers with a decimal point, meaning they can represent fractions of numbers. Then you have objects. This can vary in type. It can either be string or string and integer in a mix. So before we would have just seen a little preview of our data, but what we could do is we could see how many non-null values are in our columns and the data types. So to do that, we just use the info function method, in pandas that is used to print a concise summary of the data type, including information about data types, non-null values, and the memory usage. So here we can see patient ID is an integer and the 64 is 64 bits. Patient race is an object. And then here we have BMI, which is a float. Also, we can see here the amount of non-null values. So we can see these two, 14 and 15, have very little non-null values, and they are objects. So what we're going to do next is that we want some basic statistics of the training data. So to do that, we will have this describe function here. And basically what that is going to show us is the count, so the number of non-null values in each column, the mean, which is the average of the values in that column, STD, which is the standard deviation of the values in each column, and then the minimum value, which is the minimum value in that, the smallest value in that column. Also, you will see 25%, 15%, 75%. So what that means, that is the quartiles of the values in each column. So the 25th percentile represents the value below which 25% of the data falls, while same for the 75th percentile represents the value of these 75% of data. The 50%, which is the median, is the middle value of the data set, where half of the data falls below and half above it, indicating the central tendency. And max is the largest number in that column. So here I will just run the describe function on my train data. And here at the bottom, if you scroll down, you would actually see this is 8 rows, 70 columns. So the 8 rows is just the count, mean, minimum, but you will see 70 columns. So when we had imported our data, we would have seen 83. So some of those columns would have been not numerical. So basically, it just shows you the numerical columns. So from looking at this, let's look at patient age, which is right here. So you can see the count, and then you can see the min, but you also see the smallest value, which is 19, which means 19 years old. So that's the youngest person that is in this data. Then you will have the oldest person, which is 91. So that is the range of people that were considered for this data set. So then if you just want to display your numerical columns, you can use this command here. And what it does, it selects the types that include a numerical value. So once that is run, we will see all of the columns that have values that are numerical. So we can just
jump in 1 second. Does anybody have any questions so far? If you have any questions, feel free to stop Malini and let her know, right? Okay, Malini, you can go ahead.
Okay. So, right, this is just all of our columns with numbers. So here is just a little recap. So while you have your notebook and everything in it, you could add some text to just remind you of, your numerical columns, which is continuous and which is discrete, and just to point that out. So then we will only want to display our categorical columns. And to do this, you would see previously what we would have passed was NP number. Over here, we would just include object. And once that is run, we will see all of our columns that has characters in them, or in some cases, characters and numbers. So at the bottom here, you would see your 13 columns And for the previous one, you would see you have 70 columns. So that adds up to the 83 columns. And here is just a little reminder about categorical data. So data types are important. It's important to look at your data and see what you have. The reason for that is, so regression is a machine learning algorithm, and this only uses numerical data. But if you have some categories, like we would take payer type, for instance. So earlier when we would have looked at Google Sheets, we saw there were three categories. So basically what you can do here is that for commercial, you can let one represent that, two represent Medicare Advantage, three represent commercial. So we can do that, and you would still be able to run a regression on that data. So it's just some transformation you would have to do. So another thing is that in your data set, you can have duplicate rows. So to do that, and if you have duplicate rows, you could also drop them. So dropping duplicates in data set is a way of cleaning it and ensuring that the data integrity and remove redundancy. So here I have the name of my data frame, and then I use the function drop duplicates. And if it's true, I want to drop it. So what I would do is that just to see the shape after I drop it, that means the number of rows and columns, I'm seeing a question here. So NP number, I'm just going to scroll up here, is because I just want the columns that are numeric. I saw Videsh would have responded. So I hope you understand. If you don't, you can just put on your mic or respond in the chat. Okay, thanks Videsh. So back to where we were. So if I run the shape function, I would see that the dataset actually has no duplicate rows, which is good. But then again, there's a lot of missing values. So missing values and knowing the amount of missing values in a dataset is crucial for assessing data quality, guiding pre-processing decisions, ensuring the model performance, preserving statistical validity, optimizing resource allocation, and maintaining transparency in data reporting and analysis. So here is how we're going to find our missing amount of missing data in each column. So I would use the variable name missing values, and what I'm going to do is train data where it is null. I'm going to add the sum of it. So if all of the rows in that column, once it's null, it adds it. So it counts it like 1, 2, 3, and whatnot. And then I want to print the columns and how much missing data. So here we would have that. And you can see some columns are actually missing quite a lot. So over here, we would see the number of rows and columns. And this here, we would see the number of missing values. And we can see these two here are quite high. Now, since they're so high, it will be better to just drop these columns. Because if you keep them and you just use like a mean, mode, median, it doesn't make sense. So it will be better to just drop them. So these is just 3 are missing in these columns. So this brings us to the end of this notebook.